For the final project in my class that I taught last term in sustainable civil engineering, I had the students work on a variety of projects. So you can see the projects that we looked at. These are all related to civil infrastructure-based projects. And what I had them do is I had them perform research on the projects. I asked them to look at what the real need is of the project, to look at what the true purpose is of the project, and where that project fit in a desired end goal of what they wanted to achieve by doing that project. I had them look at impacts on the environment, impacts on the local community, impacts on the local economy. And I also had them look at assessing this with a sustainability rating system. And in the end, I had the students determine, is this sustainable? Okay, so they had to evaluate all of the research that they did and come up with a rationale that supported that project as well as a rationale that opposed the project. So answering the question, is it sustainable, is not an easy thing to do, right? There's not a right or wrong answer with this. So the students really had to think critically about the research that they were doing to really come to a determination, at the end. And one of the interesting things that I found with this was that some students who had the same project, different teams, one determined that it was a sustainable project and one determined that it wasn't a sustainable project. And so if we look at something, for example, the carbon dioxide injection wells that you see up on the screen, carbon sequestration is an important piece of balancing changes to the carbon cycle and counteracting the emissions of CO2 into our atmosphere. But this particular method of injection wells leads to its own safety concerns when we're looking at the pipelines and the wells themselves. So again, not a really easily discernible answer in determining if it's sustainable or if it's not. So let's look at what we mean when we talk about sustainability. When we talk about sustainability, we're looking at our use of resources in the environment, our use of societal resources, and our use of economic resources, as well as impacts in each of those areas. And so this particular model looks at the environment as having resources that are limiting growth in the inner circles. So economic growth is limited by resources available in society, which is limited by resources available in the environment, okay? As well as looking at impacts in each of those areas. And I want to pair this with the intergenerational definition of sustainability from the Brundtland report, where we're really looking at the use of these resources that we have available for us today and still maintaining enough resources for future generations to also meet their needs on a quantity and quality level, right? So having the quantity of resources available, but not causing too much of an adverse impact that we're reducing the quality of those resources as well. This is one of my favorite quotes by John Mueller, and this really exemplifies what we mean by systems thinking. Okay, so when one tugs at a single thing in nature, he finds it attached to the rest of the world. So this is an important concept that I really emphasize with my students. And first, we emphasize this by looking at biogeochemical cycles. So we look at cycles of carbon, nitrogen, and water in particular. And we look at how if you tug on one piece of that cycle, or if you make changes to one piece of that cycle, you really have impacts on the entire system, right? On all pieces in that cycle. For example, I'm a civil engineer. And so as civil engineers, we design infrastructure. When that infrastructure is built, we change the natural landscapes to impervious hardscapes. So if we think about the hydrologic cycle, the natural process of infiltration of water going into the ground is stopped by those impervious surfaces. So again, tugging on that infiltration process of the cycle leads to a change in our surface runoff, leading to more flooding. But as scientists and engineers, we can think critically about that and analytically and come up with some resolution to that problem. So one thing that we do in stormwater management is designing bioretention cells and infiltration basins to try to mimic that process of the hydrologic cycle, again, trying to remedy the issue of the impervious surfaces. So when I teach biogeochemical cycles to my students, it's the reasoning and the intention is twofold. I want them to understand these global cycles and understand from an environmental literacy perspective, have knowledge of these, but also to really start to instill that systems thinking process with them. So another way that I look at systems thinking is in my senior capstone design course. And so in this course, our students break off into individual technical design pieces. And when they're working on their technical design piece, sometimes they forget about all the other aspects of their design project. And so one way that I had them really come together and connect is that they had to create a systems concept map. And so you can see some images of them doing that. Okay, so they're creating a systems concept map where each bubble represents each of their technical design components. And then they have to look at all of the interactions and interconnectivities and interdependencies among those components. Again, so after they do that, they visually see, oh, if I tug on this one or make a change in my design here, that's going to impact this piece and this piece and that piece. And so they really can visually see that happening. And so when we look at it from a systems perspective and we see all these components that are interacting and interdependent on each other to provide some common purpose, right? Whatever that end goal is of their particular design. So in addition, I have them dig a little deeper into looking at all of those connections and thinking about potential unintended consequences of implementation of their design. And what type of impacts might their design choices and their design decisions have from an environmental perspective or on the community or from an economic perspective. And similar questions like, what type of material are they using? Where is that material coming from? How has that material been sourced? So even looking at something like material selection has a big impact on potential unintended consequences. Okay? So in that, we get into looking at life cycle assessment and life cycle of that material. So you may have wondered what we're doing with this paper cup. Right? So my example for a life cycle assessment is I bring in a simple product, right? Very, very simple product of just a simple paper cup. And if we look at all of the stages of that paper cup, okay, going from a tree, being harvested, being turned into pulp, being pressed into paper. This particular cup is white, so it's been bleached, right? There's some sort of wax coating in the middle. Other cups will have ink or any sort of branding label on it. So we look at then, and then after it gets shipped to the store, it gets used and it gets disposed, right? So covering all of the potential, all of the life cycle stages of that product. This being a simple product. So when we get into more complex products, you think of just a huge amount of data that can be collected in one of these assessments. But then we want to identify our system boundaries, right? What stages are we going to assess through this process? And then we look at the inputs, okay? Looking at the material inputs, material and energy going into that system. And then looking at the outputs. What type of emissions or waste do we have going out of that system? Okay? And then within those material and energy flows, we're looking at what kind of impacts this has, right? Looking at resource consumption, looking at habitat degradation from that resource consumption, looking at these emissions and looking at what these emissions lead to, right? If we're looking at emissions of CO2 leading to impacts of global warming, for example. Okay? So, one of the fun projects that I'm working on now is a sustainability teaching network, and you see right in the center of the slide. So my colleagues, doctors Rebecca DeVasier and Mark Minster, are helping lead this workshop. We have 10 different departments represented in this workshop and are in this network, and we have 15 participants. So we really have a multidisciplinary view of faculty members who are interested in incorporating sustainability into their classroom. And so one thing that we discovered when we asked, when we first joined all of our faculty colleagues together, and one of the common hindrances of incorporating sustainability into their courses was that my course is already full. Right? I have this much content I need to cover in my course, and that shelf is full. And if I try to add one more thing onto there, something else has to come out. Okay? So one of the things that we try to support each other through that network is understanding the different techniques and frameworks and tools, as I mentioned, for example, one with the life cycle assessment of material selection, but also just looking at the context in which they are presenting problems to their students. Right? Can we bring in some awareness of sustainability in the context of this statics problem? Okay? Can we look at the carbon footprint of this particular material that you're assessing in mechanics of materials class? Right? So by bringing in that context of sustainability and that awareness of sustainability, we're not needing to lose any content that goes along with that. Another important piece that I strive to focus on in my classes and share is the key competencies for sustainability. So this was published by UNESCO in the Education for Sustainable Development along with the United Nations Sustainable Development Goals. So when we have students and we enrich them with these skills where they're able to see their role in society, where they're able to understand that there are different societal norms and values depending on what community you're working in, and understanding those different sets of perspectives and skills, and being able to analyze those objectively, and being able to collaborate with people from other disciplines and other perspectives, and then bring that together in a strategic approach that's integrated for their problem solving, they really are more capable of being able to come up with a design solution that is appropriate for the community in which they're working. So now I just want to go through a couple examples of what we've done on campus outside of the classroom. So we have our campus garden, which I like to refer to as a sustainability makerspace because, we're an engineering school. And so within that space, it's really a living laboratory that has so much potential for student and faculty collaboration on different projects. There's raised beds for growing produce. There's a greenhouse. There are solar panels that are intended to supply power for ventilation of the greenhouse. There's a pavilion for an outdoor classroom out there. So much potential that we have out there for potential projects. One particular project that was a few years ago now is we had a group of students who were involved with Engineers for a Sustainable World. And their particular project that they were looking at was monitoring the energy generation from the solar panels. And then we had sensors inside of the greenhouse that were monitoring temperature and humidity. They were collecting the data from the temperature and humidity sensors inside the greenhouse and comparing that with temperature and humidity data from the weather station outside of the greenhouse to help optimize conditions within the greenhouse. So this particular project was highlighted in the ESW, Engineers for a Sustainable World newsletter for that month. So this is just an example of one of the projects that Sustainability Makerspace provides opportunities for. A couple other examples of taking students off campus. And so recently, a few months ago, we took students to an Engineers for a Sustainable World conference. And at that conference, they were able to network with other university students to share ideas on what they're doing, and network with potential employers from different sustainability-related careers that were there. And then along with my colleague Mark Minster, who was teaching the course, we took a group of students to Belgium and the Netherlands to see what types of projects and activities were being done there related to food, water, energy nexus. So that was kind of the focus of the trip. And then we also met with other university students there as well. So when we look to the future and we see these huge challenges, right? The grand challenges that were established by the National Academy of Engineering related to carbon sequestration methods and managing the nitrogen cycle and providing clean drinking water, and the United Nations Sustainable Development Goals of affordable and clean energy, of looking at responsible consumption and production. These are big challenges, right? These are really global overarching challenges. And by instilling a mindset of sustainability in our students through these key competencies, we can provide them with an awareness and capabilities to tackle these challenges that they'll see in their future careers. So predicting and responding to major impacts that we have on the environment, on our society and economy, climate change, for example, right? It's imperative that we're able to address these impacts for the future of our civilization. But the ingenuity and the talent that I see in our students can be channeled to help foster flourishing and resilient communities. Thank you.